Newton had a thought experiment about orbits, and he started off with the idea of projectile motion. Projectile motion is a bit like when you throw a football or kick a soccer ball. It has an arc which comes back to the Earth, and that arc is dependent on how hard you kick it and what angle to the horizontal. Now, if there is no air resistance, it has only one acceleration, and that's towards the center of the Earth, and that's about 9.81 meters per second squared. Now let's launch horizontally. Horizontally, when it starts, has no vertical component. So let's just watch. So get my cannonball. There we launch, and there's the track. But let me split up the components second by second, and we begin to understand something. Initially, the red component is for the horizontal component. There is no vertical, it's only horizontal. A second later, 2 seconds later, 3 seconds later. Each time the red arrow horizontally remains constant, but the vertical green arrow, which is the vertical velocity, gets bigger and bigger each second as it accelerates downwards. Now what's most interesting, as long as you have the same height and the same gravitational field, no matter how fast you launch it, it will have the same time of flight. So let's now launch it at a higher velocity. Yeah. Launch it there, and then we can see its track. Same time of flight, further distance, greater horizontal velocity. Same again if we launch it even faster. And there we can see the track. So Newton said, let me apply this idea to an immensely tall mountain or tall tower, and I'm going to launch a cannon, again horizontally, at much higher velocities. Here we go. And it travels a large distance. Launch it faster horizontally, it moves even further. But can you notice that the Earth, as it's spherical, is kind of falling away in that trajectory? And if you launch just at the right speed, what do we get? A perfect circular orbit. So that's a little bit like a circular orbit. It doesn't have to be circular, it could be elliptical. Imagine here you are in your spacecraft, you're the astronaut, cosmonaut, taikonaut, whatever you want to call yourself, and both of you are experiencing the same acceleration because you both are at the same place in the Earth's, or it could be the Moon's, gravitational field. Therefore, you have the same force per unit mass, and that's what acceleration is. So, between you and the spacecraft, there is no acceleration. There's no relative acceleration. There is no force, unless you literally push yourself against the side, and then you'll just float away from there. So why is there no apparent gravity in orbit? Both experiencing the same gravitational field strength, both have this same acceleration to the planet or whatever is attracting them, so no relative acceleration between them, like being in free fall, where you no longer have a reaction force between you and what also is in free fall, perhaps your seat. So I hope this is useful. Again, if you like the video, please hit the like button. If you want to see more, then hit the subscribe button. Thank you.